Started. So, good morning, everybody. So, we are live here. This is the day two, lecture two, on building our large language model basics. So, as our practice, we will go over this lecture. So, doctor will explain, will give something. So, I will also make some. Um, so, I will also make some explanation on it. If you have any question, you can let me know. Let's get started to
Welcome to the second lecture in the Building Large Language Models from Scratch series. The previous lecture was an introduction to the entire series, and in that lecture, I described about what we are planning to cover in this playlist, and I mentioned about our end goal of learning the nuts and bolts of building a large language model. In this series, we are not just going to look at applications, we are going to understand how things really work from a very fundamental level. So let's get started. My name is Dr. Raj Dandekar, and I graduated with a PhD from Massachusetts Institute of Technology in 2022. Since 2 years, I've been in India working on our vision to make AI accessible to all. This playlist is a part of that vision. So let's get started with today's lecture. Today we are going to cover six major aspects. First, we are going to learn about what exactly is a large language model. Secondly, we are going to learn about what does large mean in the large language model terminology. Third, we are going to see what's the difference between modern large language models and earlier NLP models. Fourth, we are going to see what's the secret sauce behind LLMs, what really makes them so good. Fifth, we are going to see the difference between these terminologies which you might have heard: LLM, generative AI, deep learning, machine learning, artificial intelligence. It's getting so confusing, right? The number of terminologies just keep increasing day by day. How do we know
right.
which terminology means what? And then in the last section, I'm going to discuss about the applications of LLMs and what all cool stuff we can build with LLMs. So, with this, we'll get started with the part one or section one of today's lecture, which is explaining what is a large language model in the first place. Now, unless you have been living under a rock, it might you would have definitely heard of LLMs, OpenAI, generative AI. So, you might have heard about the term large language model, but you might not be knowing what it exactly is. You might have even used ChatGPT without knowing what an LLM is. At its simplest form, an LLM is just a neural network which is designed to understand, generate, and respond to human like text. There are two key things here. An LLM is a neural network which is designed to understand, generate, and respond to human like text.
So, I hope we are all following what Doctor is saying. So, Doctor is trying to explain what LLM means. Doctor said LLM is a neural network which is designed to understand, generate, and respond to human like. But let's see what it actually means from ChatGPT. So let's see what ChatGPT will tell us. So in ChatGPT, let's ask what is LLM? What is LLM? So uh, so can you see how ChatGPT generate text, right? The way it generate text for you. So that is what doctor is trying to say. That okay, ChatGPT said LLM stands for large language model. Large. That's number one key thing that you should know there. Yeah. Yes. It's under machine learning. So large language model. So we will get to know what language means. You know, language is um, the the natural, like, uh, let's say, the original communication way that human communicate to each other in their own unique costume, or in their own unique custom. So, so now we are now trying to build a model, AI model that understand human language. So computers naturally don't really understand what human languages are. We have to make them understand what human language are, and so improve on. So that's what basic LLM means. So, which is a type of artificial intelligence? Can you see? Model designed to understand. That's number one. They will understand human language, then they generate human like text based on large scale data. So, a data used to train this AI model to make this LLM understand human language, first of all. Then later, we now be able to interact back with you using that same human language. So, and that is basic what machine learning, AI, deep learning is all about. So, I told you that earlier that AI is divided into three parts. We have machine learning aspect, we have deep learning, we have reinforcement learning. So these three are combined to make what we call artificial intelligence. That is the intelligence that is man-made. So these models are built using machine learning techniques, particularly deep learning. Can you see? So anytime you see large language models, they are aspect of what? Deep learning, not basically machine learning, as you have asked. Did you get the point? So LLM, machine learning has its own specific usage, right? Which we will still cover, but not maybe not in this course, but we will do that separately. But large language model, right, are basically deep learning aspect. You know, I told you that AI is divided into three parts: machine learning, deep learning, which in deep learning we have large language models, right? Then we also have reinforcement learning. So they are also trained on massive data set, which can include books, they can include articles, they can include websites and other text sources. Can you see that? So to understand language patterns, grammar, context, and semantics. Now, some of the key features of LLM is that they are natural language understanding. That is, they can understand human languages naturally because they were trained using human language data. So, and that is the whole essence of machine learning, deep learning, and reinforcement learning, generally AI. So let's come back to what Doctor is saying. So we have a full grasp of what he's trying to say.
Let me explain the two parts separately. First, neural network. So I'm assuming people who are coming to the series know a bit about neural networks. If you don't, it's totally fine. I'll explain all those basics as well. But a neural network essentially looks like this. We have input data which feeds into a layer of neurons, and bunch of these layers are stacked together, and we have the output layer. The reason it's called a neural network it's because these neurons represent the circuitry in our brain, uh, or they do so in a very symbolic sense. That's why this name deep neural network comes. And deep neural networks are shown to have a huge number of applications in image detection, text generation, um, self-driving cars. Then let's say if you want to detect whether a patient has brain tumor or not, they have huge number of applications. So LLMs are essentially just neural networks which are designed for a very generic type of text related applications such as understanding, generating and responding to human like text. What does it mean to understand, generate and respond to human like text? So the simplest way to demonstrate what does that mean is taking you to ChatGPT. I'm sure all of you who are seeing this lecture have used ChatGPT. Here you can see on the drop down I am using GPT-4. You might be on GPT-4o or GPT-4o mini. So you can ask basically any question to ChatGPT. See, here there are some questions and or here there are some prompts. So I'll click on this prompt and click on plan a relaxing day. And you see, can you help me to plan a relaxing day that focuses on activities for rejuvenation? To start, can you ask me what my favorite forms of relaxation are? And you see, the ChatGPT responds like a human, absolutely. To help craft the perfect day of relaxation, could you share your favorite forms of relaxation? For instance, do you prefer spending time outdoors, engaging in activities like reading or yoga, or perhaps trying creative pursuits like painting or cooking? So I'll write here reading a book. Let's see what ChatGPT responds. And then ChatGPT says, great, reading can be a central part of a rejuvenating day. Here's a plan focused around your enjoyment. And then it tells me to do morning meditation for 30 minutes, healthy breakfast for 45 minutes, reading time for 2 hours, nature walk for 1 hour. So you can see it's almost like I'm talking with a human. So that's the second part of the LLM definition. Large language models understand, generate, and respond to human like text, and they also respond like humans. So ChatGPT, the demonstration which I just showed you, is an LLM. But what many people don't know about or they don't think about LLMs is that at the core of LLM, they are just neural networks which are designed to do these tasks. So if anyone asks you what an LLM is, tell them that they are deep neural networks trained on massive amount of data which help to do specific tasks such as understanding, generating and respond to human like text and in
So I hope you understand what it's not trying to say. That tools like ChatGPT, you know, is what is an LLM, which is what large language model. And what are large language models? As we have said, they are neural networks. So what exactly is neural networks? Neural networks are things, algorithms. Can you see the example? They are designed to function the way or to mimic the way the structure of human brains are. You know, human brains has neurons, right? And that was where they got the name neural network. So, and those neurons are interconnected together. So that was how they understood it, how human brain function, the structure. So they now build an algorithm around it to make it function the way human brain are. So the main goal of a neural network is to work like the way human brains work. But let me also give you a beautiful understanding about neural network. So let's ask ChatGPT, what exactly is neural in AI development? Then I'm now asked you to explain this concept uh, to me as if you are explaining, explaining to a beginner in the field of AI. So let's see its response. So it is important that you know what neural network is. So you will get to understand what doctor is saying. So let's start from here. It says that a neural network in AI development is a what? Is a computer program. Can you see? It's first a what? A computer program. So it's a software. It's a computer program which got its inspiration by how human brains work. So as a beginner, you should know that all of these things called AI. a careful study of how some specific things work to now build a mathematical model around it. So, for example, scientists study how human brain actually work. They took weeks, months, years to study what exactly is the brain. How does this brain work? So they began to jot down things. Oh, they know that the brain contains neurons. Okay, that means each neurons is connected to each neurons. So from each neurons they are connected. So it's now look like a web. So sending signal and receiving, some is responsible for sending signals, some is responsible for receiving signals, right? So those are the careful research that they did. They now apply, okay, they now say, okay, how can we now make this thing that we understand, how can we now put it mathematically or as a software? So that was how they now come up with something called neural network. Did you get the understanding now? So for now, what is neural network to your own understanding? Like explain it the way you really understand it now. Yeah. Please can you speak up so that my audience can hear? Neural network is like that's neural network is like that is programmed like a program to function, not as a function that to make or aspect of what we work. That makes human work. Perfect. 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 That's it. So that means you can study the way human poop, for example. You can study the way human poop and write a program. Let's argue. Hmm? Yes. Yes, exactly. So that is the whole essence. The whole essence is you doing some research, right? And understanding the way some things work, then reproducing it, that particular thing that you have gotten, reproducing it as a computer software. So, and that is the whole ideology about artificial intelligence. So, artificial intelligence, naturally from the meaning artificial. So, this thing, this mouth, it cannot, does not have the reasoning capacity, right? Does not have brain. It is a non-living thing, right? But you can as well write a program to make this mouse reasoning. So in such that when people picks it, it should behave a certain way. When people want it to do some things, it should think and do some things in a certain way. So it is possible. So the act, you giving intelligence to human, the act, you giving intelligence to non-living things rather, things that are not living, things that are man-made. You now giving the ability of the only capacity that is meant for human, giving it to non-living things is what we call artificial intelligence. And from what we have gotten, we now realize that neural networks, right, are computer programs that are gotten inspiration from how human brain works, right? They used to help computer learn pattern, solve problem, make decision. So now a computer can now make decision, right? And even when a data or task is very complex, right? So that is what we are trying to say. So let me quickly break it down for you. So think of a neural network as a machine trying to mimic how our brain works when we learn something, just like the brain, as neurons that connect and communicate. A neural network has some nodes, right? Or artificial neurons. So these nodes are connected to each other in layers, passing information between themselves to solve problems. That's why if you see that once someone have accident and his spinal cord got broken, a whole lot of things about that person will get complicated. You know why? Because the brain itself is connected to the spinal cord. So it is from that place that it gets information back to the brain, it processes it, sends it back. So once the spinal cord of a person is having issue, a whole lot of things will start getting problem. In fact, that person may not be able to walk, that person may not be able to even reproduce. A lot of things will start malfunctioning. A whole lot of things. So that is the way brains are. Once the brain is being tampered with, what is now the essence of the person again? Do you get the point? Because the whole every other aspect of human are processed by the brain. The eye, you can disconnect the eye functionality from the brain. It's connected to the brain and it receives signals from the brain in one way or the other. There is no part of this body that does not have a connection to the brain. So once that part is being disconnected, that part stops receiving signals. So that is the exact way neural networks are. They are built with nodes that are interwoven, and majorly it has three parts. The input part, which is the input nodes that takes in information. The middle part that process the information, right? And the output part that sends out the information. Does that three stages not mimic the way human brains actually work? So human brains collect information. So the eye is like the input, right? If you see anything, you are collecting information, right? And are sending it to the brain. The brain will process it and send the information out as an output back. This is exactly what you see. On naturally, the eye does not have the reasoning capacity. The eye on its own self does not have the reasoning capacity to reason, to know what exactly it sees. It is the brain that now helps the eyes to interpret what it sees and return it back to the eyes. And this is exactly what you see. Did you get the point? So that is the way neural networks are. So there are nodes. These nodes are connected to each other in layers to solve problems. So how does it work? I've told you it is of three types. There is input layer which takes in information, right? There is hidden layer that processes the information, and there's output layer that brings out the output, right? So if you can take your time to also Google some of these things and find its deeper meaning. So let's go back to
Many cases they also respond like humans. This is getting better and better as I am making this lecture, and LLMs are in fact sounding more and more like humans, and that has led to huge problems. Maybe we'll create a separate lecture series on that. So that's the first section which we dealt with today, which is what is a large language model. Great. The second question you might be thinking is, why is it called a large language model? Why not just a language model? After all, it's just a model dealing with language, right? Why do we specifically have this one more large term here? And the reason is because until LLMs came into the picture, model sizes were not very big. And when I mean model size, I mean the number of parameters in the model. But LLMs, if you know about the number of parameters which they deal with, you will be shocked. LLMs typically have billions of parameters, billion, 1 billion. It's a huge number of parameters. And now there are even some LLMs which have trillions of parameters. We can't even think of those numbers, but it's huge number of parameters. So let me show you a visual here. So this is a table which shows the number of parameters.
you cannot. Okay, uh, so what is and no, no, let me just explain. So what is trying to tell us here is that it is called large language model. So why exactly is it called large? Why can't we say, why can't we call it language model? Since it is dealing with what human language, right? Why can't we just call it language model? So he's not trying to tell us that the reason it is called large is because of the number of parameters. So we said huh? number of number of parameters that the neurons. We said that neural networks are the main thing that is behind large language models. So, and in neural network, let me give you picture. Let me show you picture of neural network. Picture of neural network so that I can use that to explain. Let me take which one? Let, let me first of all, I wish I can increase this. I can't increase it. Let me just see. Let me visit. Let me see. Please. So let me see. Let me see. Okay. Exactly. So can you see? So look at. I hope this thing. I'm not buying. Sorry, Jerry. I just want to explain. Can you see how human brains, like how they function inside when you use something like a stethoscope? Can you now see that something is connected to something? I wish I can increase this one. I just wish I can increase this. So something is connected. So each of these nodes, they are connected to one thing or the other. This one is connected to this big one. From there, you will see that there are tiny, tiny sources too that are connected. This one is connected to this, goes like this, goes like this, goes like this. You cannot really get a full traces of everything, right? So that is the way neural network are. But I feel, look at these things, right? Look at this particular thing. Let me show you. Look at this particular. This is an example of the neural network we are trying to say. So it is the amount of the parameters that is in these neural networks that will make it large language model. Sit up, please. So let me sit up. So it is the amount of the neurons that this particular thing is. That's why we call it large language model. If we pass, let's say, if the whole total of the neurons are two, let's say 100 layers, right? So 100 layers is smaller than 1 billion parameters. So the much parameter we use, the more the the more the AI will understand and get better. The bigger the parameter, the better it gets, right? That's why it is called large. So we have various parameters that people use to build their large language models. So that is what Dr. is trying to tell you, that this word large means the number of billions or millions of parameters that you use to train your your language models. I hope that part is clear, right? So let's continue.
There are even some LLMs which have trillions of parameters. We can't even think of those numbers, but it's huge number of parameters. So let me show you a visual here. So this is a table which shows the number of parameters in GPT. As you know, we are at the GPT-4 right now. So GPT-3, which was the earlier version of GPT, you can
Can you
see
see that?
GPT-3 small had 125 million parameters. GPT-3 medium had 350 million. GPT-3 large had
That is a
760
train.
million.
They
And
were
if you see,
trained. What doctor is trying to let us know is that if so you understand? Yeah, some of the foundational GPT. So the first one used 125 million parameters. So they kept increasing the parameters. They kept increasing the parameters until it is what 1.3 billion. So the bigger the parameters used, that's why they are called what large language models. So as at now, we still have billions, but definitely very soon we'll be having models that are trained with trillions, quinzillions, get it, in the nearest future. So let's
see
continue.
GPT-3 13B had 13 million. GPT-3 175B had 175 billion parameters. So usually the second term here is the number of parameters in the model. So here it's 175B, which is 175 billion parameters. And GPT-4 has even more number of parameters. That's why they are called large language models. So here is another graph which shows the comparison between GPT-1, GPT-2 and GPT-3. So as you go from GPT-1 to 2 to 3, the LLMs also become better and better and better, but their number of parameters also increase tremendously. If you see from GPT-1 to GPT-2, there is a factor of 100. So the parameters increase from 100 million to almost 1 billion. So actually there is a factor of 10 here. But from GPT-2 to GPT-3, there is a factor of 100. So GPT-2 had only 1.5 billion parameters, but GPT-3 had 175 billion parameters. You see, there are some other terminologies also, like GPT-1 had 12 decoders, GPT-2 had 48, and GPT-3 had 96. If you don't know what this means, it's totally fine. We are going to cover that in this series. Token size. Take a look at token size. GPT-1 has a token size of 512, GPT-2 has 1024, GPT-3 has 2048. It's fine if you don't know what it means, just you can see everything is generally increasing. Now, here is a graph which shows the model size in artificial intelligence type of models over the period of years. So, this graph is plotted for
Yeah? Yes. Yes, that is yes, that is the aspect of we will we will we will get started. So we'll be doing it one one by one. That was the aspect I started with that day. That you were saying.
from
Come on, let us finish this.
1950 to 2022, and it was
Start
published in Nature. So it is a reliable graph. On the y-axis, there are a number of parameters. So if you see in 1950, number of parameters was around just 10 to 100 uh, in a log scale. So this y-axis is in log scale. So 1950 to 1960, models barely had 1,000, 10,000 parameters. Then in 1980 to 2000, models started having around 100,000 parameters. But it's only in 2020 that we have reached 100 million, 1 billion, and even almost close to 1 trillion number of parameters now. And you can see the orange symbol here. So mostly these parameters are for LLMs, which is for language tasks. I'm just zooming in here to show you that the orange symbols here have the largest number of parameters. I hope this has convinced you why these models are called large number of models. We are living in an age where the number of parameters are unprecedented. They are huge number. That's why it's called as large language models. I'm sure by the time this video is released and maybe 1 year after that, we would have reached the parameter size of 1 trillion. Now, the reason that's the first part of the terminology, large. Then, why are they called language models? And that's pretty clear if you remember the example which I showed you over here. These models only deal with language, they do not deal with other modalities like image or video, let's say. They only deal with language. LLMs only deal with language. So these models do a wide range of natural language processing tasks. So anything related to language, such as question answering, translation, sentiment analysis, and so many more tasks, which all of you definitely might have explored with ChatGPT. That's why they are called language models because they generally do a wide range of tasks related to language. So this is the meaning behind the terminology large and language models.
So you have seen that these models have various things like use cases that can be used for. Can be used for question and answering, translation, sentiment analysis, and much more. Right? Let's get
That
started.
covers the second aspect of today's lecture. And now we come to the third aspect, which is why have LLMs become so popular? Didn't we have the field of natural language processing before also? And that's true. Natural language processing as a field has been existing much before LLMs. NLP models have been existing much before LLMs. But NLP models, if you look at the models which came before LLMs, they were designed for very specific tasks. So, for example, there is one particular NLP model which might be designed for language translation. There might be one specific NLP model which might be for sentiment analysis, let's say. LLMs, on the other hand, can do a wide range of NLP tasks. So it turns out that if you train a GPT for text completion, that same architecture works well for language translation also. And it's pretty generic that way. That's one difference between LLMs and earlier NLP models. Earlier NLP models were designed for specific tasks. Modern LLMs can do a wide range of NLP tasks. The second difference is based on an application. So earlier LLM models could not, earlier LLM models or earlier language models, I should say, could not write an email from custom instructions. It was very difficult for them to do that. Now, if you think of modern LLMs such as ChatGPT, and this task is almost trivial for ChatGPT. So if I go to ChatGPT right now and I say, draft an email for me to send to a colleague or to send to a friend of mine to book movie tickets, let's say, and I'll just zoom in here and see ChatGPT not only starts drafting the email but it also has inserted emojis and everything here. It's a trivial task for ChatGPT, but you might be surprised to know that this trivial task was very hard to do for earlier NLP models. And that's the big difference between LLMs versus earlier NLP models. They are broad.
So now you now have an understanding of the difference between what LLM is now and what it was in the previous years. So now LLM can now do various things. LLM can help you to write your email, can help you to even solve the internet, can help you do a whole lot of things, right? So that is what LLM can do now. But earlier, they can't do something that they are built for specific use cases. That's what we are trying to give you the differences of the progress that has been done from the beginning of AI development research in the world and what AI is now. That there have been a very far improvement and definitely what it will look like in the next 10 years will be far better than what we have now. So that's what we're trying to let you know about. So let's get back.
They can do a wide range of generic tasks. And second is their applications are endless, much more than the earlier models. And that's why we are even having this playlist in the first place. So that's point number 3. Point number 4 is what you all must be thinking about, that LLMs are so good, they can do these amazing tasks, they can almost behave like humans, right? But what makes LLM so good? What is the secret sauce? Typically, there has to be a secret sauce, right, which makes LLM so much better than NLP. What's that magic bullet here? And usually people say that there is no secret sauce to things, things just gradually improve over a period of time. But in this case, there is a specific secret sauce, and that is the transformer architecture. So you see here I've added the logo of secret sauce. And for LLMs, the secret sauce is transformer architecture. Don't worry if you know what it means.
So what we are now trying to tell you is that LLM, large language models, so there are secrets to what makes them do what they do. So the secret is what? Transformer architecture. So if you can deeply understand what transformer architectures are, and you can deeply maybe write your own or do a costume transformer architecture, then you can make an LLM behave in a certain way. For example, if you are trying to make a model that can predict or that can place a bet and predict accurate bet, right? You can build a model to understand the the information about what bet are, the kind of bet you want to do, and what are the previous bet scores and the rest of them. So once you now understand, you will now create your own transformer architecture to make it to understand and behave in that particular manner. So the secret to LLM, doctor say something that there is difference between NLP and LLM. NLP means natural language processing. Let me even ask ChatGPT, is there difference? Is there is there difference between NLP and LLM? Let's ask, let's see what it will tell us. Okay. Can you see? It said what? Yes. So there's difference between NLP, which is natural language processing. That is, you are processing natural human language. You want to process it, you want to change it from your English to Yoruba, English to French, English to any language that you want. You get translation. While NLP is large language model. So he said, yes, there's difference between NLP, which is natural language processing, and LLM, which was large language models. But they are closely related concepts in the field of what? AI. So what is NLP? NLP is a branch of artificial intelligence that focuses on enabling computer to understand and interpret to generate human language. So the ability for a computer system to understand human language, let's say Yoruba. So can a natural computer system understand Yoruba? Can even a non-living thing understand human language at first? No. So normally non-living things rather, non-living things cannot understand human language and they cannot respond to human language. But if you now give that non-living thing the ability for it to be able to perform the way human being does, that's when you are now giving that non-living things the power of what? Artificial intelligence, which we can refer to as what? A natural language processing, which the computer now understand human language, interpret human language, and even generate human language, which includes wide range of tasks like spoken or writing and rewriting. So which LLM, we have talked about LLM, right? Which is specific type of what? machine learning model designed to perform many NLP. So let's get back. I hope some of these concepts are being cleared gradually. So once you start machine learning, you will really get everything clear. So once this lecture finishes, we now start our main machine learning immediately. Or do you want to rest? So I can give you a break time for you to rest. Then we'll come back for our.
What is Transformer? For all you know, you might be thinking of the Transformers movie, in which there are these cars which get converted into mechanical robots. So you that might be your first thought when you hear about Transformers, right? Of course, people who know about this know exactly what I'm talking about here. But for people who don't know, this is the only Transformer. If this is the only Transformer you know, this playlist is perfect for you, because you will understand what does transformer really mean. And what it actually means is it's summarized by this one schematic over here. This is what a transformer architecture looks like. And you might be confused by all of these terminologies. What is input embedding, what's multi attention head, or what's feed forward here, what does add and norm mean here, what's output embedding. There are so many things which look confusing, and it's fine. But we are going to learn about this secret sauce in a lot of detail in this playlist. There is one paper which was introduced in 2017 which really changed the game. That paper is what I'm showing you on the screen right now. It's called Attention is All You Need. It was published by 8 authors from Google Brain, and this introduced the architecture of transformers. So the schematic which I showed you on the whiteboard is this schematic which they had in the paper. Can you guess how many citations this paper has today? It has more than 100,000 citations in just a matter of 5 years. So people say that research is boring and research does not have any external reward. In this case, it does. If you are one of the few authors on this paper, you have 100,000 citations in 5 years, and you completely revolutionize the field of artificial intelligence. So this is that paper, and it's a 15-page paper. But if you try to read it, it's very dense. To understand this paper really takes a lot of time, and it really takes a lot of effort. There are some YouTube videos to explain this, but I don't think any of them do justice to really explaining everything from scratch. Every single page of this paper can be 3 to 4 videos. So if you think about it, these 15 pages contain huge amount of information, and we'll be devoting lectures to different sections here, such as positional encoding, what is this dot product attention, what is this attention formula, what is key query value, what is multi-head attention. We'll be figuring all of that out. So don't worry at this stage if you don't know what a transformer means. Even if you have just this image in mind of a transformer, it's awesome. You have come to the perfect place.
So so
Okay,
so can you
so
now see that everything about LLM is mathematically calculated? They are what mathematically calculated. So that is what um, so you need to have understanding of mathematics and statistics so that you can grab at least better. So that's what we're trying to see there. So let's get
So,
started.
as I said, do not worry, we will learn all about this secret sauce, which is the transformers, in the subsequent lectures. That covers the fourth point of today's lecture. And now we come to the fifth point, which is all about terminologies, right? So, there are so many words people are throwing around randomly these days, right? It feels it's just getting confusing, more and more confusing. So, people talk about LLM, people talk about GenAI, they talk about deep learning, they talk about machine learning, and artificial intelligence is one more term. What are the similarities, what are the differences between all of these terms? So if you look at this particular graph here or figure, it kind of sums up everything perfectly. Start from the outermost sphere, or the broadest domain, that is artificial intelligence. That is the biggest umbrella. Under this big umbrella comes a smaller umbrella, which is machine learning. Under this machine learning comes yet another smaller umbrella which is called deep learning. And within that, the smallest umbrella, that's the large language models. And this is what we are going to make a playlist on, or this is the playlist which you are watching right now. So what's the differences between these? So first, the broadest umbrella is artificial intelligence, and this contains all the
So can you now see that large language model can also be called a grandson of what? Machine learning. Large language model is a grandson machine learning. So machine learning, this is the grandfather, AI, which gave birth to what? Machine learning. So machine learning is the father. He gave birth to what? Deep learning. So in deep learning, you now have a large language model. So you cannot isolate machine learning from what? From large language model. So large language model still is under what? Machine learning. Did you get the part? And its major power behind it is what? Deep learning neural network. And what makes it a source is what? The transformer. So let's continue with our class.
other umbrellas. So any machine which is remotely behaving like humans, or it has some sort of intelligence, that comes under the bucket of AI. That's the biggest bucket. So you might be thinking, what's the difference between AI and ML, right? So look at this example. This is Lufthansa flight chat assistant. And so it says, "Hi, I'm Elisa. I am your Lufthansa chat assistant. Here is a selection of topics I can help you with. You can choose one of the topics." So then you say, "Hi, Eliza." Then Eliza says, "Hello." Then you can click on any one of these. You see, it's a rule based chatbot.
What's it?
You click some options, and then Eliza is already programmed to
Yes,
answer.
exactly.
So I say that flight cancelled, check alternatives and rebook. So if I click on this, Eliza is already programmed to answer. This is an example of AI because it covers intelligence, right? Lufthansa chat assistant can be thought of to be intelligent. But this is rule based intelligence. It's not learning based on your responses. So let's say you respond and your friend responds. Eliza, this chat assistant, will behave the same way. It's not learning based on what you are giving it or your specific nature as a user. So that's why this is not an example of machine learning. It's an example of AI, but it's not an example of ML. And that's why AI comes under the broadest or the biggest umbrella. Within that comes ML. If you look at ML, this is basically machines which learn, they adapt based on how the user is interacting with them. So you might be thinking, okay, that's fine. Then what's the difference between ML and DL? Why is DL a subset of ML? The difference is that deep learning usually only involves neural networks, but machine learning involves neural networks plus other fields. And one such field is decision trees, right? Let's say if you want to predict heart disease. So if you have data from 303 patients, and if you are collecting things like age, gender, chest pain, cholesterol level, ECG, etc., you want to predict whether the person has heart disease or not. And you build a decision tree like this. Now, a decision tree like this does not have neural networks at all. This is completely detached from neural networks. So, this is not an example of deep learning, but it is an example of machine learning. A deep learning example would be something which involves a neural network. So, for example, here we are, this is an image detection, and here is a convolutional neural network. So, we have a coffee cup here, and we are detecting based on these filters. So there are filtering layers in this convolutional neural network, and at the end of this filtering layers, we are detecting what this input is, whether it's a lifeboat, whether it's a pizza. So with maximum probability, we are saying it's an espresso. So a neural network is being used for this task. That's an example of deep learning. Another example is, let's say if you want to predict handwritten digit classification, right? So if you train a neural network like this, if you start training, so here you can see the neural network is being trained, and the problem here is handwritten digit classification. So I have given it a bunch of digits, which actually look like this MNIST data. It looks like this. I've given this neural network a bunch of digits to learn from. And the task of this neural network is, whenever I give it or whenever I write a new digit, it should identify whether what digit is it. Now, if you see this particular example, this is actually an example of neural network. So here you can see the neural network architecture. We have the input layer, we have the hidden layer, two hidden layers, and then we also have the output layer over here. This is an example of deep learning. So now if you click on test, and if I select this, let's say I select this and click on predict, you see the neural network is correctly predicting 8. So it's understanding the digits. Let's say I click on this and predict, it's correctly predicting 7. This is an example of deep learning. That's why deep learning is a subset of machine learning. Machine learning involves these kind of neural network architectures, plus it involves things which are not neural networks like decision trees. Now, within deep learning is LLMs. Why? Because deep learning, as we saw, involves images also. But large, like this involved images, even this project involved images. But large language models do not involve images, they only deal with text. And that's why they are a further subset of deep learning. This is the difference between AI, ML, DL, and LLM. So then you might be thinking, what is generative AI? Generative AI you can think of as a mixture of large language models plus deep learning. Why? Because generative AI also deals with other modalities like image, sound, video, etc. It deals with all of those modalities. So it is definitely, you can think of it as a mixture of large language models plus deep learning. So if someone asks you what is generative AI, basically we are using deep neural networks to create new content such as text, images, various forms of media. Whereas in LLM, you only deal with text. So generative AI can be thought of as a mixture of LLM and deep learning. I know these terms are confusing, but I hope these examples help you understand what's the similarities and differences between these terms. As a summary, you can think of as AI to be the broadest umbrella. Within that comes ML, within that comes DL, and within that comes LLMs. And AI is artificial intelligence, ML is machine learning, DL is deep learning, and LLM is large language models. And if you mix LLM plus deep learning, then we have generative AI. Because in the field of generative AI, we don't just deal with text, but we deal with other modalities of media like image, like audio, like video, etc.
Do not use Microsoft Excel without ChatGPT and AI because you're wasting.
So LLMs just represent a specific application of deep learning techniques which leverage their ability to process and generate human-like text, which we have already seen. They basically deal with text. So this is the similarities and differences between AI, ML, DL, LLM, and generative AI. I hope you have understood this part and you like these visuals. If you have any doubts until this part, please write it in the YouTube comments and we will answer as quickly as possible. And now we come to the last part of this lecture, which is applications of LLMs. And
So do you understand? Okay, so you don't have any question? If you have any question, you can still send them to my DMs. So let's continue.
as I speak, the applications go on increasing, but overall they can be divided into five main categories. LLMs, as number one, they can be used to create new content, of course. So if I write here, write a poem about solar system in the format of a detective story. Maybe this content does not exist anywhere right now, but you can create this content using LLMs. So here you can see there is a poem about solar system in a detective story format. In the quiet sprawl of the Milky Way, a detective roamed the stars by night and day. His name was Orion. In cosmic affairs where mysteries burst. The case on his desk dance quite bizarre. Yeah, I won't read the full poem, but here you can see you have created new content. You can even write books with LLMs, generate media articles with LLMs, and people are already doing these things. Then you can use LLMs as chatbots. So you can actually interact with them as virtual assistants. So here you see at the start the example which I showed you, it's like I'm chatting with this LLM, right? It asks me what's your favorite form of relaxation. I say reading a book. I can continue conversations with it. And not just for me, big companies, airlines, then hotel reservation desks, they need chatbots, right? Let's say you call a customer care representative. In 5 years, it's highly likely that all of those people are AI chatbots. And how are they built? They are built through the knowledge of LLMs. In fact, through this lecture or through this playlist, rather, we will be building our own LLM. So you will be fully equipped to develop your own chatbot in any field which you like. So chatbots is one of the huge and major applications right now of large language models. Banks, movies, restaurants, all of them need chatbots. When you're booking shows, when you're dealing with the bank, you want to know how to open an account. All of these are going to be automated and are already being automated through LLMs. That's one of the biggest applications. And through this playlist, you will learn the skills to develop your own chatbot. Then the third application is machine translation, which means that you can of course translate the text to any language, right? So then I say basically that translate this poem to French, and here you can see that ChatGPT is working on this translation and immediately it translates
Yes,
into
you
French.
can
We don't even need Google
translation. You can
Translate now.
translate it
I'm
to
sure this
fast.
translation is accurate because it's amazing at this translation tasks. So you can very quickly translate the LLM's output into any language, and it does have some support for regional languages. Not a very broad support, but it does support few regional languages. In fact, a lot of research is being done to improve the LLM outputs for regional languages. For regional languages. So that's point number three. Point number four, which we saw already, is new text generation, such as writing poems, writing books, writing media articles, news articles. It can basically create new text for you which did not exist before in literature. And finally, LLMs can also be used for sentiment analysis. You can give a big bunch of paragraph and ask the LLM to identify whether what is the sentiment here. This might be useful for hate speech detection, let's say on social media like Twitter, Instagram, etc. So all of these five applications are the pillars of LLMs and what they can do. There are several more applications which I'm probably missing right now, but these five are the major ones. To illustrate these applications, let me just take you through a portal which we have recently created for school teachers. So here you can see we have created this portal by learning about LLMs ourselves. So here it's YouTube generator, MCQ generator, text summarizer, text rewriter, worksheet generator. We can do so many awesome things. Let me go to the lesson plan right now and say that I want to create a lesson plan on the topic of gravity and I want to align it with the CBSE curriculum of India. And let me click on generate.
So my point is this: you do not need a
So can
big
you
audience
see
to make money online with school.
the various things that
So you will see
you
that the
can
LLM is
can
working on
you
it a
can
bit
create anything. You
and it
just be
does
like
take
God.
some time, but
You
now you
can
can see
create
the lesson
anything
plan is created
once
for
you have
gravity,
the
where
understanding
we
of
have the
this.
objective, we have the assessment, key points, the opening, the introduction to new material, guided practice, independent practice, etc. This would save so much time for the teacher. And it's amazing. This was not possible 5 years back. But now with the LLMs, we can do all of these applications. We can do so many other cool things such as uh, text MCQ generator. Let's say you are a teacher and you want to generate the questions on, let's say, World War II, and you want one hard, one medium, and one easy question. You click on generate and you wait for the response of that LLM. You see immediately within 5 seconds we have got question and answers for World War II. We have three questions, we have their correct answer and the explanation. We built this LLM from, or rather we built this LLM application from scratch. And once you go through this playlist, we will have several lectures towards the end which will show you how you can also build such type of applications. But here I want to illustrate the point that if you have knowledge about LLMs, the sky is the limit. You can build wonderful applications like this. And what many students do wrong is that they get so fascinated by these applications that they just download the code, they run the code, they make some changes, and they write on their resume that they know about LLM. That's not the right way. The right way is to understand the foundations, make your basics clear, understand the nuts and bolts of LLMs, which is the purpose of this playlist. So this is section 6, which is the application of LLMs. And now we have completed the 6 sections which we have planned for today's lecture. At the end, I want to leave you with just one sentence, and that is the sky is the limit when it comes to LLM applications. please remember that the applications which I just showed you right now are just the tip of the iceberg. You can do so many things right now if you learn about LLMs. That's what's so exciting about the time which we live in currently. Uh, the sky is the limit for research applications, for industrial applications. But what we think is that students who will really contribute and make an impact are the ones who know the details of how to write the transformer code, how key query value works, what exactly is positional encoding. Until you understand these concepts, it becomes difficult. Your knowledge will be superficial. And that's the whole purpose of this playlist. Please comment in the YouTube comment section if you liked the style of this content description, if you liked the this whiteboard approach. I'm basically trying to write everything here and give a visual flavor and a visual intuition for how things are working. In subsequent sections we'll definitely dive a bit deeper into coding. The next lesson, as I mentioned here, is stages of building LLMs. We'll have couple of lectures about these basics and then we'll be diving into coding. So make sure you're understanding, make sure you make notes and ask questions in the comments.
So thank you everybody.
Hey, I'm Joey.
So we will meet next time in our next class. So get ready for the coding and we'll meet next time. Thank you. So if you have any question, you can let me know why I would answer them correctly. Thank you.